Hello, I am Luis Fernando Mesa Torres, and today I'm going to talk about Kary Mullis and his contribution to biotechnology. Kary Mullis was an American biochemist who invented the polymerase chain reaction, known as PCR, a technique transformed fields like molecular biology, medicine, and biotechnology. This discovery allows scientists to amplify DNA quickly, accurately, and efficiently. And this making it one of the most important tools in modern society. So, Kary Mullins was born on December 28, 1944 in the United States and passed away on August 7th of 2019. He earned a bachelor's degree in chemistry from Georgia Institute of Technology in 1966, and later he completed his PhD in biochemistry at University of California, Berkeley in 1972. After his doctorate, he worked in medical research and teaching, and later he joined to Cetus Corporation, where in 1983 he developed the technique that would change biotechnology forever. Okay, as I said, in 1983 Mullins invented the polymerase chain reaction. PCR allows scientists to create millions of copies of a specific DNA segment from a very small sample. Before PCR, analysis DNA was slow, expensive, and complex. With PCR, only a tiny DNA sample is required, making research faster, cheaper, and more precise. This discovery had a huge impact, especially in red biotechnology, which focus on medicine, health, and diseases diagnostic. PCR works through repeating cycles of a heating and cooling in a machine called thermal cycle. This machine carefully controls temperature, changing the allow of DNA to separate primers to bind and new DNA strands to be synthesized. Each cycle doubles the amount of DNA, leading to exponential amplification, allowing millions of DNA copies to be produced in just a few hours. For example, here we have the first thermal cycle, the TC1 DNA thermal cycle using by Kary Mullis. The PCR process has three main steps: the desnaturalization, annealing, and extension. During desnaturalization, the DNA is heated to about 94 to 96 centigrados, causing the double strand DNA to separate into two single strands. During annealing, the temperature is lowered to about 50 to 65 centigrades, allowing primers to be completely sequenced. During the extension, the temperature increased to about 70 centigrades, and DNA polymerase synthesizes new DNA strands by adding nucleotides. For example, here we have like the complete cycle view. Each PCR cycle includes the three steps: the standardization, that is here, the first one, annealing, and synthesizing. Each cycle doubles the amount of DNA. After the first cycle, one DNA molecule becomes two. After the second cycle, there are four. After the third cycle, there are eight, and this doubling continues exponentially after 30 to 40 cycles. So, scientists can obtain single original fragment. This exponential application allows scientists to detect extremely small amounts of DNA, making an essential for medical diagnostic, forensic science, or genetic research. So, due to the enormous impact of PCR, Kary Mullis received the Nobel Prize in Chemistry in 1993. His invention revolutionized biotechnology, molecular biology, microbiology, virology, genetics, and medicine. Today, PCR is used to detect infections, diseases, identify genetic mutations, for testing DNA analysis, and conduct paternity tests. Okay, now let's talk about ethical debates. PCR is a fundamental tool in genetic engineering, which leads to ethical debate, as we know. So, these include the limit of human intervention in nature, safe concern, moral questions about altering life forms, privacy, and misuse of genetical data, and the risk of false accusation due to DNA analysis errors. So, all of these debates highlight the need for ethical responsibility and regulation in this field. So, Kary Mullis discovery transformed modern science and a global healthcare thanks to the polychain reaction. Scientists can detect diseases faster, allowing early diagnostic and treatment which saves lives. PCR supports vaccine development in medical research, forensic science, and genetic engineering. So this reminds us as a fundamental laboratory tool in the worldwide. So in conclusion, Kary Mullins changed the world of biotechnology forever. His invention of PCR remains one of the most important discoveries in the modern society. So with these tools, scientific have ever created like millions of lives have been saved, and science has advanced a lot in this last century. For this reason, Kary Mullins is considered one of the most influential scientific in the modern society. So I hope you know more about Kary Mullis, and thank you very much for your attention. And here I have my sources, well, reference. So now I have a question for you. What is your opinion about the PCR techniques? How reliable do you consider it for disease detection? What advantage and disadvantage limitations do you think it has? And how important do you believe it has been for diagnosis, prevention, and scientific research in recent years?